lab experiments. We already discussed first 7 lab experiments. Now we are going to discuss the 8th lab experiment. Now let us see the question. Okay, the question is design a Verilog program to implementing the various types of flip-flop such as SR, JK and D flip-flop. Before going to the code, let us know about D flip-flop. It is an electronic device that is known as image flip-flop or data flip-flop. It stores a single bit of data. The D flip-flop may be synchronous or asynchronous. In this experiment, we are discussing synchronous version of D flip-flop. For synchronous version of D flip-flop, the clock signal is required, which can see in a Verilog program. Okay guys, let us see the Verilog code. This is the Verilog code of D flip-flop. The inputs are D, CLK and RST. CLK means clock and RST means reset. The output is Q and QB. QB means Q bar. Always at the positive edge of clock, the output will changes. If the reset is 1, then the output will be always 0. The output depends upon the present input of B. If B is equal to 0, the output is 0. If B is equal to 1, the output is 1. We assign QB as a complement of Q. And this is the characteristics equation of D flip-flop. Q of T plus 1 is equal to D. And this is the function table of D flip-flop. The input is 0, the output is 0. The input is 1, the output is 1. We are going to see the two types of D flip-flop. That is, one is master slave D flip-flop and another one is edge triggered D flip-flop. We are going to execute in the lab edge triggered D flip-flop. Hi guys, welcome to the lab session. This is the last lab session of DDCO of 2022 scheme. Let us simulate the D flip-flop first. This is the Verilog code. Let us simulate it. Okay, let me give the value for D, force constant, and the value is 0. For CLK, we should go for force clock, not force constant. We should go for force clock. And leading edge value should let me give as 0. And next trailing edge value let me give as 1. And period let me give as, we should give as 1 US. And reset value is also as usual as force constant. That will I will give as 0. Okay, now let me should put F7. We should not forget this. The 1 US came. Let me run the code. Yeah. If the D is 0, CLK is 0, reset is 0, the Q is 0 and the Q bar is 1. And now I will change the D value to 1. Change the D value to 1. Okay, now let us check the output. Yeah, if we change the D value to the 1, the CLK is 0, reset is also 0, Q is 1 and Q bar is 0. This is D flip-flop. Okay, now let us discuss the JK flip-flop. The JK flip-flop is also known as Jack Kilby flip-flop. JK flip-flop is an edge triggered flip-flop. The output changes when a clock pulse is applied to a clock input. So this is the Verilog code of JK flip-flop. The inputs is J, K, CLK and RST. CLK and RST means clock and reset as usual. Output is Q and Q bar. Always at positive edge of clock, the output will changes. If the reset is 1, always the output will be 0. Else the output depends on sum of J and K. The sum of J and K is represented in a flower bracket of J comma K. And we assign QB is equal to complement of Q. This is the Verilog code of JK flip-flop. Now let us see the characteristics equation of JK flip-flop. The characteristics equation is Q of T plus 1 is equal to J Q bar plus K bar Q, and this is the functional table of JK flip-flop. If the input is 0 0, the output Q of T means it will no changes. If the input is 0 1, the output is 0. If the input is 1 0, the output is 1. If the input is 1 1, the output is Q bar of T. means complement. So next we are going to see the circuit diagram. Okay, this is the circuit diagram of JK flip-flop, and this is the graphical symbol. So let us execute the code in the lab and let us see the output. Okay guys, now let us simulate the JK flip-flop Verilog code. This is the Verilog code. Let us simulate it. Okay, we should press F7 as usual. Okay, we should give the input for, let me give the input for J. J I will give as 0, and for K I will give as 0, and for clock we should go for force clock. Leading gauge value always it should be 0, and trailing gauge value always it should be 1, and period I will give as 1 US, and for reset I will give 0. Okay, let us see the output now. Okay, the output is x for q and q bar, because the value of j and k is 0, so the output is no change. Okay, now let me give another input. Let me give input for j as 0 only and k as 1. We will give the value of k as 1. Okay, now let me run the program. Yeah. You can now you can see that the output Q becomes 0. Now let me change the value of RST to 1. 1. Okay. If we change the value of RST to 1, no matters what input, the output will be 0. Okay guys, so now let us discuss about SR flip-flop. SR flip-flop is also known as set reset flip-flop. Here S and R are input control states of flip-flop. It is a basic flip-flop which stores a single bit, single data vector. It results in invalid output when both inputs are 1. And this is the Verilog code of SR flip-flop. The inputs are S, R, CL gate, RST, CL gate is clock, RST means reset. The output is Q and Q bar. Always at positive edge of clock, the output will changes. If the reset is 1, the output always will be 0. Else, the output depends upon the sum of S and R. The sum of S and R is represented in the cover bracket, and we assign QB is equal to complement of Q. This is the Verilog code of SR flip-flop. And this is the characteristics equation of SR flip-flop. The equation is Q of t plus 1 is equal to S plus R bar into Q of t. And now we are going to see the logical diagram of SR flip-flop. This is the logical diagram of SR flip-flop, and this is the functional table of SR flip-flop. So let us execute SR flip-flop in the lab and let us see the output. Thank you. Hi guys, now let us simulate the Verilog code of SR flip-flop. This is the code of SR flip-flop. Let us simulate it. Okay, we should press F7. Yeah, it is on US. Let me give the value of S as 0 and R as 0. And CLK we should go for not for force constant, we should go for force clock. It is mandatory that leading edge will be 0, trailing edge will be 1, and period is 1 US, and RST is 0. Okay, now let us check the output. Okay, S and R are 0, so output is no change. Now let me change the value of R from 0 to 1. Okay, now let us see the output.
Now you can see the output. If we change the value of R from 0 to 1, the Q will be 0. Now let me change the value of reset. Reset to 1. Now let me run the code. If no matter what the input is, if reset is 1, the output will be always 0. So this is the Verilog code of JK, SR and D flip flop. Thank you.